Hey guys, if you need this video paused, make sure you just say something in the sub. Sure, go pause it if you need to. I'm going to be doing the calculator stuff up here, so you do not have to have one in front of you. I just want you to kind of follow along because I'm not there to help you. But today we're finding holes and asymptotes. And yeah, go ahead and giggle, and everybody does that as that title. I assume you know what holes and asymptotes are. A hole in the graph is literally just that, a hole. Now, it may be just a hole or it may be filled in somewhere else. We don't know. It could be one of the two. Now, we've seen functions like this before. We've had holes. But we've especially seen asymptotes, like on tangent and everything. It's when a function, there's an asymptote there, gets closer and closer and closer, but never actually gets there. So today we're finding holes of a graph and asymptotes. We're not going to worry about horizontal asymptotes today. That will come with calculus. It's much easier to do with calculus. Okay, so first thing, we're going to use a calculator to find the holes and asymptotes. Now make sure you write these directions down, otherwise you'll look at your notes wondering where we got the answer. We're going to use your calculator to find the holes and asymptotes. Of f of x equals x minus 3 over x squared plus x minus 12. Now, a function could have one hole, it could have one asymptote, it could have one of each, it could have two asymptotes, it could have three asymptotes, it could have one hole, two asymptotes. It could have a whole different combination of two, and it can have none, of course. We know many functions have none, like parabolas, cosines, sines. So we don't quite know. We don't quite know. So what I'm going to do is I'm going to graph this. And I already have my graph, but of course, make sure you're in function mode. And you just simply graph the function. Okay. I'm in my standard viewing window. So it looks like there's an asymptote right here. That looks to be about -4. I'm going to write that down. At x equals approximately -4 is a vertical asymptote. And I must identify what it is. Does it appear to have any holes? I don't see any. Do you? But I'm going to check my table. And to do that, I'm going to go to Menu, Table. I'm going to do split screen so I see both. So I see this and this. If I scroll back, maybe, here's your x values and see at -6, -5, but then at 4, it's undefined, -4, which makes sense because we know there is a vertical asymptote there. It is not, doesn't exist. But if I scroll down, at 3, there's undefined again. But at 3 on this graph, I don't see anything. And that's because your graphing calculators, even as great as these are, will not show holes. The table will, the graph won't. So there is a hole at x equals 3. Let's try another. My calculator or my video might die on me. It's not fully charged, but we'll see. We'll get as much as we can in. So f of x equals 2x plus 3 over 2x squared plus 5x plus 3. Okay, the first thing I'm going to do is, of course, graph it. And hold on, I'm getting a cord to plug in the camera here. So it looks like it's about ready to die on me. Give me 1 second. Ignore that. And that is not good. We'll pause.